And finally, this is that equation that is too stubborn to balance. And in this video, I am here to balance it the Chemist AI way. So stay tuned. The Chemist AI method of balancing this equation is what I call the LCM method. In this method, you don't have to do the endless trial and error that leads to cancellation. The LCM method is therefore the only convenient method you can use to balance chemical equations, especially the stubborn ones. Now, in balancing chemical equation, what you do is to rewrite the equation. So we rewrite the equation. So this is the unbalanced equation. Now, in the LCM method, you first of all list the elements that participated in the reaction and write their number of atoms at the left and their number of atoms at the right, and then create space for the LCM of this number of atoms. Now, the first element you are seeing here is potassium, and potassium is 2 at the left hand side but 1 at the right hand side. The second element is chromium. Chromium is 2, you can see it there, 2 at the left hand side and 1 at the right hand side. The next element on the line is oxygen. Oxygen is 7 at the left, and when you check at the right, it is 1, that one that exists in water. The next element is hydrogen. Hydrogen is 1 at the left but 2 at the right. Finally, the next element is chlorine. Chlorine is 1 at the left, you can see it, and then 1, 4, 6 at the right. But these 6 exist in 3 different compounds, so you write them separately: 1 in potassium chloride, 3 in chromium 3 chloride, and 2 in chlorine gas. And then we are ready for the LCM method, the Chemist AI way of balancing the equation. Now, quickly we look for LCM of 2 and 1. Of course, that is 2, right? How do we get 2? That is 2 times 1, because when 2 multiplies 1, we get 2. And when 1 multiplies 2, we get 2 also. Therefore, we come back to these 2. This 2 is going to multiply 1 to get 2. And this 1 will multiply 2. So 1 times 2. You are going to implement this in the real reaction equation. 2 is going to be written at the right hand side, that is at the back of potassium chloride, to balance potassium. The next is chromium. LCM of 2 and 1 is also 2, and this 2 means 2 times 1. There is 2 at the left, you multiply it by 1, and the 1 at the right you multiply by 2 to get the same number. Because of that, you go to the right and say 1 times 2 by writing 2 at the back of the compound in order to balance chromium. Chromium is now balanced: 2 at the right, 2 at the left. The next element is oxygen. 7 at the left, 1 at the right. Now, LCM of 7 and 1 is 7, right? And this 7 means 7 times 1, which means 7 times 1 is 7 and 1 times 7 is 7. So 7 times 1 is already 7 at the left, but 1 at the right will be multiplied by 7. You write 7 at the back of water. Now the next element is hydrogen. Hydrogen is 1 at the left and 2 at the right. But these 2, if you go to the equation, hydrogen is no longer 2. It's 7 times 2, 14. So 2 has become 14 at the right. Therefore, you are going to look for LCM of 14 and 1, not 2 and 1. So 14 and 1, the LCM is 14, and this 14 means 14 times 1. You are going to go to the left and multiply the 1 by 14, and then write 14 at the back of HCl to balance hydrogen. You can see hydrogen is 14 at the left and also 14 at the right. Finally, chlorine. Remember, there are 3 numbers at the right, so you treat them separately. And this 1 at the left is no longer 1, it's now 14, right? So now let us see if the chlorine atoms at the right are balanced. The chlorine in potassium chloride is no longer 1, so you multiply by 2, as there is 2 at the back of KCl. Also in chromium 3 chloride, the chlorine there is 2 times 3, so you write 3 times 2. 1 times 2 is 2, 3 times 2 is 6. We have gotten 2 plus 6, but the number at the left is 14. We have gotten 8 plus what will give you that 14. Therefore, we multiply this 2 by 3 and write 3 at the back of chlorine at the product, so that 2 plus 6 plus 6 will give you 14, as it is also 14 at the left. And this balances chlorine. If you check the equation, you will see that it is already balanced. So we rewrite K2Cr2O7, that is potassium heptaoxodichromate 6, plus 14 HCl to yield 2 moles of potassium chloride plus 2 moles of chromium 3 chloride plus 7 moles of water and plus 3 moles of chlorine gas. And if you check, the equation is very balanced. If you found this video useful, don't hesitate to comment, share this video, tag your friends, and subscribe to my YouTube channel, Kemis AI Educational Consultancy.